All right, let's go over some things here. We'll first do our linear regression t-tests assignment, our first assignment here. So here we were asked to see if there's statistical evidence of a linear relationship between the amount of food that is fed to the dog and the dog's weight. So the intent, so it does say, so for a while, there's question as to which one of these variables is X and which one of these variables is Y. And so here it says that we are going to be predicting the dog's weight. So that right there is going to indicate to you that this is Y and this is X. I had some problems in the past where these were actually written in the opposite way, and I could see how you could predict the amount of food from the dog's weight. So I could see it making sense. Therefore, I stopped and made sure I understood which variable was X and which variable was Y before I began. Okay, so we are predicting the dog's weight. So slope of the beta is the slope of the relationship between the dog's weight and the amount of food fed each day. We were wondering if there is a linear relationship, so 0, and then this is just talking about predicting. It never gave me an indication thinking it was negative or positive. And so therefore, I just used the not equal to symbol here. It was stated that the conditions for inference have been met. Yay. And this is a linear regression t-test for slope. You could put for slope there. I think I had done that on the notes. Now, I had gone and put those two lists into my L1. Of course, I had done this one for L1 and this one for L2. And then I went and ran a linear regression t-test. So stat over to test. I go up from the bottom. So state these things. T-score is 6.73, the p-value, and the degrees of freedom. So don't forget about that. That was from these 10 pieces of data n minus 2 for the degrees of freedom. So my p-value is quite low. I'm rejecting HO. So since that p-value is less, there seems to be evidence of a linear relationship between the amount of dog food a dog is fed in a day and the weight of the dog. So it seems like we would have the right to predict the dog's weight based on how much it eats in a day. All right. Now I threw in something else to you. I said, hey, this S on the calculator printout is the standard deviation of the residuals. And we'll talk about this a little bit more later, but also don't forget that in the notes yesterday, I mentioned how another way to write the standard deviation of the residuals is S with a little subscript E for the standard deviation of the errors, how far off the errors are, the residuals, the actual is from predicted. All right, so that's telling me 4.86. So let's do that interpretation. So the average amount that the actual Y, which is the actual dog's weight, varies from the predicted dog's weight, is 4.86 pounds. And our units would be the Y units. Okay. All right, next. We then did this with a computer printout, and we had a random sample of 14 cities. And it's if you had one of the pages picked up today in class, if you had one of the packets that I handed out in class, this random sample of 14 cities, that information may have been missing. So you need to fix that. All right, well, let's go here. Oh, state and interpret the standard deviation of the residuals in context. Okay, so remember this S of E is the standard deviation of the residuals. That's there. Remembering this is B. The little b is the sample's slope. So that one sample's slope. This is the standard deviation of that one sample. S with the little b there. Okay, so 5.454. So let's see, we were, This was, okay, I can see this is my explanatory variable. So we were attempting to seeing if we have a linear relationship to be able to predict the average amount of ozone from the population. Okay, so average ozone level is the Y. Okay, oops, let's do that here. I wanted to write that the average ozone level is Y because that's my explanatory. All right, so the average amount, that the average ozone level, and I might have should have put the actual average ozone level, varies from the predicted average ozone level, is 5.45 parts per million. That was the units for that. And part B, standard deviation of the slope. So that is this 1.91. So if we sample many times, I'd expect the slope you find of the relation between average ozone level and city population to vary 1.91 parts per million per population million, because I'm trying to there put the units for the slope. And the units for the slope would be, you know how slope is the rise over the run. So the units for the slope would be that y unit over the x unit. So the y units was parts per million, and the x unit was population in millions. So it's parts per million population million. All right, so given the conditions have been met, determine if there's evidence of a linear relationship. Beta is the slope of the relationship between those things. Null hypothesis, zero slope. Alternatively, it didn't say one way or the other. Just said, is there a linear relationship? Okay, so two-tailed. So this is going to be informative when we come down here and calculate the p-value. So let's pay attention here. Conditions for inference have been met. Whew, I think I might have messed up on my p-value. So let's talk about it. Linear regression t-test. Okay, so our t-score. So remember that our t-score comes from our sample slope minus our hypothesized slope over that standard deviation of slope. So was that sample slope 16.65? Okay, yes. All right. So look at there, I got this. And so that's, way out there. Of course, our degrees of freedom were 12 because there were 14 cities, and 14 minus the 2 is 12. Now, that's about 0. You know what I did not do? I forgot. This was a two-tailed test. Two-tailed test. Get the p-value for two tails. It's actually not going to change my problem because this was so small. But, I need to multiply that by 2 to get that p-value for two tails because this is just one tail. Still actually pretty much going to be 0, okay? But, I had forgotten that. All right, so our p-value is less than alpha. Since the p-value is less than alpha, I reject HO. There is evidence of a linear relationship between the population and the average ozone level. Okay, makes sense to me. But now we have statistical evidence of it. I think I'm going to do this multiple choice in a separate video. That will also include the AP Tester Trio in it, the review questions. All right, so I'll see you in the next video.